this is written. Okay, so a scientific notation example would be if you had 3.07 times 10 to the eighth power. Okay, it is written as a number times 10 to an exponent. Okay, let me try to, it is kind of small. There we go, that's better. All right, so you have your number, then you have 10 raised to a certain exponent. This exponent can be positive or negative. Okay, so a couple things to remember as well is large numbers these have positive exponents. Okay, so large numbers have positive x numbers. These are numbers that are greater than 1. Okay, positive exponents. Small numbers have negative exponents. These are numbers that are less than 1. Okay, so any number less than 1 has a negative exponent. All right, so things you need to think of is, why do we need scientific notation? Okay, because when you have scientists or mathematicians or engineers or whoever it is working on a certain project, they deal with very, very, very large numbers or very, very, very small numbers. And instead of writing that big, long decimal out on a piece of paper or writing that big, long number out on a piece of paper, it makes our work very simple, very small, and easy to get to our solution. Okay, so you might be sitting there thinking, well, Mr. Reed, I don't want to be a scientist. Okay, that's great, but think about people that deal with technology every day, the apps on your phones. Okay, there's certain programs and things they have to write and have to deal with numbers, very large and very small numbers. Okay, so with that, you need scientific notation to kind of help you navigate those things very easily. All right, so let's look at converting scientific notation. Okay, so converting to, and I'm going to abbreviate, okay, scientific notation just kind of helps us get through our day faster. All right, so we're going to look at an example first. All right, we're going to convert 3,285,000 to scientific notation. All right, we're going to convert this big number into scientific notation. So the first thing we're going to do, we're going to move our decimal to a spot that makes our number between 1 and 10. Okay, so we're going to move our decimal to a spot that makes our number between 1 and 10. So if I look up here at 3,285,000, okay, I'm going to put a decimal somewhere that makes this number between 1 and 10. I can't put it left of 3. That makes it smaller than 1. I can't put it next to 2 because it makes it 32 point something. Okay, I'm going to place that decimal right there. All right, and that's going to make that 3.285. Okay, so all we did in the first step was we moved the decimal somewhere that made this number between 1 and 10. Our second step is we're going to count the number of spaces we move the decimal. Count the number of spaces we move the decimal. All right, so how many spaces did I move it? If this number is larger than 1, your decimal is going to be at the very end. So our decimal started here, so we moved it 1, 2, 3, 4, 5, 6. Okay, we moved it 6 places. All right, so we moved it 6 spaces. That's 6 spaces. This is our exponent. Okay, how many spaces you move it, that's your exponent. Okay. Now the question is this going to be a positive exponent or a negative exponent? It's going to be a positive exponent. Why? My number is larger than 1. 3 million is definitely bigger than 1. Okay, so this will be a positive exponent. So my number in scientific notation is going to be 3.285. You don't have to put these zeros. If you do, you're not wrong. Okay? You don't have to, but if you do, you're not wrong. Times 10 to the 6th power. And that will be your final answer. You converted that number to scientific notation. Okay? Now, let's say that we were asked to take this number, okay, the same number. This will be our second example. We're going to convert from scientific notation. Okay, and we'll do that same number there. Okay, convert from scientific notation, 3.285 times 10 to the 6th. Okay, so we'll convert from scientific notation this time. So, some things to remember. So our first step, okay, we're going to move our decimal. All right, so I have 3.285. Okay, and how many places do I move my decimal? This number, this tells me how many places to move decimal. Okay, how many places to move decimal? It's a positive exponent. Okay, so we move our decimal, you need to think about a number line. Okay, so we need to think number line. On a number line, if I split this up, which direction is positive? Well, positive numbers are to the right. Okay, negative numbers are to the left, or smaller numbers. So move our decimal, it's a positive decimal. Number line positive means moves to the right. Okay, so if you want to jot that down, positive exponent, right, negative exponent, left. Okay, so if we're moving this to the right 6 places, I'm going to go 1, 2, 3, 4, 5, 6. Okay, And I'm going to write this at step 2, although I really don't think you'll need it. All right, but we're going to write it anyway. We're going to fill placeholders with 0. Okay, so these are my placeholders. I have 3. So I'm going to go 1, 2, 3. So my final answer here will be 3,285,000. Okay, so you're just using whatever number you have here and you're moving your decimal. If it's positive, you're going to move it to the right. And if it's negative, you move it to the left. Okay, so when we're converting to scientific notation, find a number that is between 1 and 10. All right. I'll give y'all a second to jot that down, and then we'll do another example. We'll look at an example that's less than 1, and then we'll kind of go from there. Let's look at another example. We're going to convert 0.04568 to scientific notation. So when we're dealing with numbers smaller than 0, we need to find a place that makes this a number between 1 and 10. Okay, so if I place this here, that makes that 0.4. That is still less than 1. Okay, if I place it out here, that's 456, which is greater than 1. So I'm going to place my decimal between the 4 and the 5, okay, which now makes that 4.568. That number is definitely between 1 and 10. 4 is greater than 1. 4 is also less than 10. Okay, so once we did that, we need to find out what our exponent is. 10 to the what power? Okay, now I probably have questions of, do I put this 0 in front of the 4? You don't have to. You can put a 0 in front of a number that is in front of a decimal, and that's fine. It doesn't change the number, but you don't have to put it there. So I wouldn't. Okay. So now we need to determine, okay, how many places did I move this decimal? I moved it 1, 2, all right, 2 places, and I moved it to the right. But this number is smaller than 1. Remember in our notes, small numbers less than 1 have a negative exponent. So this number is less than 1, which means my exponent will automatically be negative. And that will be our final answer. Okay? So if it's smaller than 1, negative exponent. Oh, not 3. Come on, read. Example 4. We're going to convert 2.697 times 10 to the negative 5th. We're going to change this out of from scientific notation. Okay. So let's take my number. This number is already just like this. So we have 2.697. Okay. And I'm going to now look at my exponent, and we're going to move our decimal. Question is, which direction? Okay. It's a negative. Think of your number line. So right is positive, left is negative. This tells me to move that decimal to the left. So I'm going to move it to the left 5 places. 1, 2, 3, 4, 5. This is my new decimal. What do I fill these gaps with? I'm going to fill them with zeros, which gives me a final answer .0000267. And that'll be converting out of scientific notation. Okay.